Okay, so I'm going to pull my answers up. Hope everybody has had a chance to compare. So again, there it goes. Was there anything to solve here?
No.
No. Okay, so ignore those two on the bottom. We'll come back to those after our lesson. But again, all we're being asked to do is to find what each of these are. And yes, if you don't have a graph or a table, yes, you would plug in that x to figure out what the y, the corresponding y is. But in this case, they gave us a graph and they gave us a table. Okay. Did it freeze again? It did. Let me try to unfreeze again. Okay. So any questions on where any of those values came from? Are we good? Yeah. Okay. So we will move into the lesson then. All right. So today's lesson is on function operations, and we're also going to look at the composition of functions. All right, so our first operation, yes?
Is this a quiz?
No.
Oh.
So first operation is addition, where we have f plus g of x. Okay. And so again, all it is taking two functions and adding them together. The two functions in terms of x, I should say. And we can restate this as f of x plus g of x. Right. So if I have f minus g of x, what do you suppose we can turn that into? Exactly. It's just f of x minus g of x. Just restating it. Okay. And anytime you see two variables next to each other, what is the understood operation? Multiplication. Okay, so we just see this f and g next to one another. So it is f times g of x. And again, we can restate that as f of x times g of x. And then our last one, f over g of x. What do you suppose that can be restated as? There you go. F of x divided by g of x. And I'm just going to make one statement. What is the one number g of x cannot be equal to? 0. Okay. Okay, so you guys ready to apply some of these operations?
Yes.
Alrighty. So, in this first example, we have f of x is equal to x squared plus 1, and g of x is equal to 3x minus 2. So in our first example, it's asking us for f plus g of 3. All right, so it's asking us to add f and g together and evaluate it at 3. So usually on these, when we're actually evaluating at a term, it's much easier to do each one separately. So turn that into f of 3 plus g of 3. And then we'll combine them at the end. Okay. All right. So f of 3, I'm going to take that 3 and plug it into my x terms in x. So that becomes 3 squared plus 1. So f of 3 is equal to 10. And I'm also going to evaluate g of 3. So g of 3 is equal to 3 times 3 minus 2. So g of 3 is 9 minus 2 is 7. And so I can combine those together now So f plus g, evaluated at 3, is 10 plus 7, which is 17.
Why did you get 3? Yeah, wait, yeah, I'm kind of confused in the beginning.
The initial in the question? That 3?
Then what's the... Oh, never mind, just... I understand.
So because it asked us to evaluate it at 3. So we're going to plug 3 in for the x terms. Okay. Now, I'm going to show you, we could also have combined f plus g of x first and then evaluated at 3. So I'm just going to show you that and how it comes out the same. So if I did f plus g of x to start with, again, it's just adding f of x plus g of x. F of x is x squared plus 1, plus g of x is 3x minus 2. And I'm going to combine like terms just to simplify this. So we get x squared plus 3x minus 1. So if I came back now and wanted to evaluate that at 3, f plus g of 3, again, I'm going to replace all my x's with 3. So I get 3 squared there. 3 times 3 minus 1. Again, I get 9 plus 9 minus 1. Do we still get 17? Yes. Okay.
Should we do either method or should we do like the top?
You can do either one. It's just usually if you're evaluating, it's easier to do them separately. Okay. You ready to look at the second one? Yes. Okay. All right. So this one, we see fg of negative 1. So again, this is a multiplication of the two functions evaluated at negative 1. So I can do f of negative 1 times g of negative 1. So I'm going to do the same thing and evaluate these separately. F of negative 1 is equal to negative 1 squared plus 1. So negative 1 squared is positive 1 plus 1 is 2. And g of negative 1 is 3 times negative 1 minus 2. So 3 times negative 1 is negative 3 minus 2 is negative 5. And so again, I'm just going to combine them now. F times g of negative 1 is 2 times negative 5, which is negative 10. All right. And again, I'm going to go ahead and show you the other way too. Just so that you see, we're going to get the same thing. So if I do f times g of x, again, I'm just multiplying f of x times g of x. F of x is x squared plus 1, and g of x is 3x minus 2. So depending on what the question is asking, if it's asking you to, put it into standard form, then we would have to go ahead and expand this and combine like terms. But since we're just going to evaluate, I'm not going to do all that. I'm going to keep this simple, and I'm just going to go ahead and take my f times g and evaluate it at negative 1. And you'll see we get the exact same thing. Negative 1 squared plus 1. 3 times negative 1 minus 2. And in the first position, we get negative 1 squared is positive 1 plus 1 is 2 times negative 3 minus 2 is negative 5. So again, do we get to the same solution? All right. Which one's easier?
The first one.
First one is usually easier. Okay, let's look at the next one. All right, So in this one, I have f divided by g of 1. So again, I'm going to go ahead and separate it into its two pieces. F of 1 divided by g of 1. And I'm going to solve those individually. So f of 1 means I'm going to take 1 squared. Is that minus 1? Plus 1. Plus 1. Okay. So we get 1 plus 1 is 2. So f of 1 is equal to 2. And I'm going to evaluate g of 1. So g of 1 is 3 times 1 minus 2. 3 minus 2 is 1. And now I'll just combine the two together. F over g of 1 is 2 divided by 1, which is 2. And then just so that we see, we could also have done it as f over g of x, where we would just have f of x over g of x. And again, this would just be the x squared plus 1 all over 3x minus 2. Right? And again, you could evaluate it doing this way. So, unless they specifically ask me to divide this out and go further, I would not. I would just leave it in this format. Okay. Last one here. This is an f minus g of x. So they're not actually asking us to evaluate this one. We're just straightforward using it with x and going to simplify it. So again, this is the same thing as f of x minus g of x. And f of x is x squared plus 1 minus g of x is 3x minus 2. What do I need to include? What was that? Parentheses. Okay, so be careful on these subtraction ones because you have to subtract the entire polynomial, right? Not just the first term. Okay, so this is actually x squared plus 1 minus 3x plus 2. And then we'll go ahead and collect our like terms to make this look nicer. X squared minus 3x plus 3. And that is f minus g of x. Okay. So what do we think of function operations? Pretty straightforward? Yeah. Okay, bless you. Okay. So the next thing we want to look at are what we call composite functions. Okay, so what happens with composite functions is you are composing one function with another one, right? Which just means we're going to plug one function into another. So the notation for this is going to be this open circle here, okay? So when you see an open circle between two letters of a function, you want to recognize it as being a composite function, not a multiplication, okay, but a composition. So this one would be read as f of g of x. And what it means is we are going to compose the function f with the function g. Right? So again, g is being inserted into f. So does the order in which you read it matter?
Yeah.
Yes. Okay. All right. So we can also think of this as f of g of x. Okay. So again, this is the inner function, and this is the outer function. All right, ready to try some?
Yep.
Yay! Are we all just tired today?
Yes.
Yes. It's only Tuesday. I know, it kind of does feel like a Wednesday. That makes for a really long week, doesn't it? Okay, so we've got two functions here again. F of x is equal to x squared plus 1, and g of x is equal to 6x. Okay. So in our first example, it's asking us for g of f of negative 2. So which one is the inner function? The f. And then the outer function is the g. So we're going to compose the function g using the function of f, but we're evaluating it at negative 2. Okay, so I'm going to rewrite this. This is the same as doing g of f of negative 2. Yes?
Where did the why didn't you put a 6 on the 6x with the g?
Because I haven't taken care of it yet. So it's the outer function, so we do that last. Okay, so kind of you want to think about the order of operations. Order of operations always says to do what first?
Parentheses.
Parentheses. Okay, so think about what's on the inside. That's what we want to treat first. Solve the inside function, and the inside function here is what? F of negative 2. So I'm going to do that here on the side. So f of negative 2 is equal to, and I look at my function f, which is x squared. So I replace that x with negative 2 squared plus replace x with negative 2. All right, so that gives me a positive 4 minus 2, which means f of negative 2 is equal to 2. And so now I'm going to replace this f of negative 2 with its actual value.
So 6x times 2?
Not 6x times 2. Oh, yes, because I'm going to, sorry, I was going the in-between step. So this becomes now g of 2, and now we're going to apply the function g. And g is 6x, so it becomes 6 times 2 equal to 12. All right. So g of f of negative 2 is equal to 12.
Wait, is it not 12x?
No, you remember you're replacing. Anywhere you have an x, you replace with the value that's inside. Okay, so what do we think of that one? Is it okay?
That was pretty good.
Pretty good? Hooray. Okay. Are we ready to look at B? All right, so B is f of g of 1/3. So again, I'm just going to rewrite this as f of g of 1/3. Okay. Which one is my outer function? F, and my inner function is g. G of 1/3, and that's where I want to start. So I evaluate g of 1/3, which is 6 times 1/3, and that gives us 2. And so again, I'm going to replace my g of 1/3 with the 2. So now I have f of 2, which I will now evaluate. So this is 2 squared plus 2, which is 4 plus 2 is 6. So therefore, f of g of 1/3 is equal to 6. So I missed breakfast this morning and my stomach is growling and I'm hoping it doesn't get picked up on the recording. If anybody listens later and you hear this low rumble, then you'll know. It's not a haunting. It's just my stomach. Okay. All right. Here's our last example. It's f of g of x. So what's changing in this one? We don't have something to evaluate, okay? And so these tend to be a little more challenging for students, okay? Because we're having x's and then we're replacing x's with more x's. But it's the same exact thing. The outer function is f, and we're going to build the function f with the function g of x. Okay. All right. And so just like we did when we had a term that we were evaluating at, I'm going to replace my g of x with g of x. So this becomes f of 6x. And what does that tell me to do? Okay. Into every x that is in the g of, into f of x, exactly. Okay, so my first x term in f of x is x squared. So I'm going to replace that x there with 6x, and then remember to square it. And then the next term is just a single x, so we replace that x with 6x. All right, now I just want to clean this up a little bit. 6x, all of it squared is 36, x squared plus 6x, and that's about all we can do with that. So f of g of x, I mean, you could factor if you wanted to, but there's really no need. This is pretty much in standard form, so we're happy with that. Okay, so what do we think of our composite functions? All right. Okay, here are 4 for you guys to try on your own. And I'll come around and answer questions if there are any. There we go.
Is it not?
Okay.
I didn't have the X.
How'd we do?
Yeah. Oh, okay. So you don't simplify anything. Oh, okay.
No.
Yeah.
So it's not wrong if you do. It just depends on the form that you're being asked to put it in. Yeah. It just depends. I think you're in the book. Well, I'm giving you a worksheet for homework, but in the book they typically expand everything out. But you know, that's just extra work. So I'd rather leave it like this. Okay. So any questions overall on these? Okay. I want to circle back to the warm-up that we did because sometimes you're not given equations, but you're given tables instead, like in this case here, where we're just given the graph and a table. Okay, so like the first one, I wrote that in, f plus g of 0. What is that asking us to do?
It's to evaluate
Okay. Do we know what f of 0 is?
Yes.
What is f of 0? Is -6. Do we know what g of 0 is? Is 8. We just add them together and we get 2. Okay, was there anything to solve here? No, other than combining them, okay? So remember, if you're given a graph, you know what all the inputs and outputs are. You don't need to solve for coordinates. They're there. Same thing if you're given a table. There's nothing to solve there. It's already given to you. How about the next one? G of f of 2. What would we do with that one?
F of 2. So F of 2 is 0.
F of 2 is 0.
G of 0 is.
And G of 0 is 8. Exactly. Did everybody catch that? Yes? Okay. All right. So that's all we have for today. Yeah.